All right, we should be rolling here. So I'm gonna do a quick, maybe not really quick, but I'm gonna do a video on different types of pilot assemblies and pilot hoods and what they mean and what they're for and how they work. So there's three types. One is the standing pilot assembly, which is in my hand currently. There's going to be an intermittent spark pilot and then an intermittent hot surface igniter pilot. So we'll get started with the standing pilot. So standing pilot ignition system, you're going to come across, looks like this. This is part number, for those that are interested, this should be part number Q327A1626. And there's another one here that's also standing pilot. I thought I grabbed two out of the back. I guess I didn't. But nonetheless, all the same. So these pilot assemblies, how they work are you have a thermocouple, okay? And that thermocouple generates a millivoltage of about 30, and that goes into here. So the flame is hitting it, okay? Flame on these has to hit the top 1/3 of this probe here, okay? Not down here, you know, up here, top 1/3, in order for that to act, you know, work properly. They usually come with various, depending, I think this is a Basso brand. Honeywell's a more common one. And these thread into here to kind of hold it into place, all right? And sometimes there's a little pinch clips. Let's see that picture here, this bag better. Okay, and those will fit in there as well, and that holds that in there. So these pilots, the way this order of operations work is that this pilot is always lit 365 days a year. This goes into the gas valve, basically allows, I'm not gonna get too into that, but that lets the gas valve know that, you know, the pilot's lit. Okay, that's a safety. On a call for heat, the only thing that happens is the gas valve receives 24 volts in common to open up the main part of the gas valve, and this is burning a flame off here, and the burner is right here. And when the gas starts to come out of the burners, it hits this flame and everything ignites, and you're good. So if it doesn't ignite, then you're not good, but eventually it'll light. And if the burners that are close to this standing pilot assembly are covered in rust and soot or stuff like that, then you could get a delayed ignition, because the gas from this burner may not be catching, but the gas off of this burner is just building up, and all of a sudden, it all lights real quick. So you always want to, and the other thing is you get a lot of carbon and soot buildup nearest these pilot assemblies because the flame is constantly hitting the burner. So you want to, you know, when you're doing cleaning checks, make sure you're cleaning that really well. What supplies the fuel to this? Well, it supplies the fuel is the same to all these pilot assemblies. It's a aluminum 1/8 inch aluminum, or excuse me, 1/4 inch OD, 1/8 inch pilot. This stuff is very bendable, flexible, so you shape it however you need it. Typically they come with, you know, an end for your pilot assembly here, and then one that, or excuse me, this one goes on your gas valve, and then so the gas valve basically not only just lets out, for these pilot assemblies, not only just lets out fuel for the burners, but also has another small port that lets out fuel for the pilot assembly too, okay? So that's a standing pilot assembly. Always has a flame, and it'll allow the main burners to light as long as that this thermocouple is working, top 1/3, setting a 30, you know, millivolt voltage back to the gas valve, okay? I'm trying not to rush this, but there's a lot of information, so we're just kind of doing a touch on this. So the next one we're going to go over, and then I have some pictures too that I found online that we'll take a look at those as well. The next one's going to be an intermittent pilot, spark pilot. So the difference between the intermittent pilot or spark pilot and the standing pilot is it's kind of the next step up in next advancement in technology, if you will, okay? That's this. This also uses this to feed gas through here, okay? And it difference with this one is there's not always a standing pilot, like I said. It's usually wired to an ignition, or pilot ignition control module, okay? And it uses what's called I refer to them as a high tension wire. It almost looks like a spark plug wire you would see on a car. So what happens is when this module receives voltage from your thermostat on a call for heat, this spark probe, this is basically screwed in, so that's creating like a grounding surface. So this spark probe right here shoots out a voltage and creates a spark between this probe here and then the hood right here. And simultaneously, the gas valves that are used with these have, a pilot valve and a main burner valve and a common. But initially, and you can see that that's marked onto this module. Let me open this up out of the box here. So, try not to sound too confusing, but if you look on here, okay, MVPV and then MVPV, this is your common, and these tie into your gas control valve, okay, for this specific. This is your pilot. So on an initial call for heat, it will, you have your 24 volt common, it'll send out 24 volts as it also is sending out spark through this probe right here to that sparker. And simultaneously it'll allow the fuel to flow through that burner hood, okay? And then the spark hits and that ignites. Now, this here also does a sense. So if you see right here, so it's backwards view, but it says sense right here, spark and sense. It waits till, it'll keep trying to ignite. In this case, I think it's 30 seconds or trial for ignition 90 seconds. So it will keep trying to ignite until this senses a standing pilot flame, okay? Then once it senses the pilot's lit, then it'll continue to send, 24 volts common, and then it will send out your 24 volts on your main gas valve, which therefore lights the burn, or sends fuel through the burners. The burners hit the pilot that's shooting off of this, okay, and then you get ignition. Okay, so when you're doing maintenances on this stuff, a lot of times it's easier to replace these, but you want to make sure at the very least you're cleaning these probes as if you would a flame rectification probe or a flame sensor with a piece of sand cloth or emery cloth. But then you want to use a little bit of alcohol to get the silica off of there. Okay. Now back to the standing pilot one, I was always taught that the manufacturers recommend replacing these thermocouples annually because for reliability reasons. Doesn't mean you necessarily have to. I've seen them last 3, 4, 5 years, but for reliability reasons, you want to. They're not very expensive, okay? Because this always has direct flame impingement on it, you'll see that these start to melt down and they get worn out. And then there's actually, you don't want that to happen. Let's leave it at that. And, so you want to replace these annually, okay? So like I said, that's a standing pilot. And this last one we talked about is a spark pilot ignition that is usually always paired with a pilot, module, okay, ignition control module, and utilizes a spark plug wire or high tension wire, and both utilize this fuel tubing, okay? The last one we get into is going to be your intermittent pilot / hot surface ignition pilot. Now, the difference with that one is this. It doesn't have a standing pilot, okay? It doesn't have a spark probe. What it actually has is a little hot surface igniter that glows red hot. Now this fits into a pilot assembly. I'll show you a picture in a second here that also has a fuel tube on it. So, and this has a plug, a 4-port plug, and utilizes 3 here. And this is what is found on a Honeywell smart valve. Some guys refer to it as dumb valve system. So on a call for heat, once it goes through its pre-purge checks and all that, the first thing that happens is this igniter here glows red hot. Then after, I think it's maybe 5 or 10 seconds, I'm guessing at this point, to be honest with you, then another pilot hood, which is not this pilot, let's use this one, not this pilot hood, but another pilot hood would let off gas. It would hit this ignition or ignite. Then this flame sensor, this is a flame sensor, it's all built together, would sense that flame, and then it would tell the gas valve basically to allow the burners to get all their fuel, and then you have, burner ignition. So let's take a look at some pictures that I found online. Let's go to that last one we just looked at. So this is the Intermittent Pilot with hot surface igniter. So that's your little igniter right there, flame rod. And this is like the pilot assembly that it fits into, or pilot burner. And there's a spring clip that comes in with the new ones that basically that slides up through there. It's like a key. So this is fatter than this one's skinny. It only fits in there one way, and then this clip goes over and holds it open, or holds it in there. And on this pilot burner is where your tubing goes to, okay? Now this picture here, a little fuzzy, is a direct spark, right? Intermittent spark ignition. Now this one here, this is different. So this one actually has a spark or a pilot relight, they call it. So I didn't really touch too much on that, but it would also utilize a thermocouple. So this is not a standing pilot. This is an intermittent pilot, but it does utilize a thermocouple, okay? This is more of your traditional, right here, your traditional intermittent spark pilot assembly. This is a standing pilot. Okay, so you can see where the thermocouple goes in here, and this would be a pilot light that's lit all the time, and then this one just has a different pattern. And that's how these hoods are all shaped differently. It's because they just, whatever the manufacturer, came up with, for a flame pattern is what these different ones are. And that's usually, see in this case here, it's directing it at the thermocouple, but in this case here, then it's also probably hitting the burner at the same time. Same thing at this one. This little hole here is hitting the thermocouple for flame safety, and then it shoots out the flame here over a burner. Same thing here, thermocouple there. This one here, okay, shoots over it and past it, and then the burner's probably over here. Same thing with this one. Now this one here, I thought we had this one. I thought I grabbed in the shop. It's kind of a cool one. This is one I would stock personally, and we do stock on the trucks. There's a little screw right here. I don't know if you can see that. This pilot hood here, you can actually take the screw out or loosen it and rotate the pilot hood to whatever direction you need it to properly hit the burners with. Okay, so yes, that's basically it. So just as a recap, we went over three basic types. We went over, we started with the standing pilot ignition that uses a thermocouple. We went over the intermittent pilot spark that, like I said, uses a high tension wire. Spark looks like a spark plug wire, which is in the packet. I didn't open it, just being lazy, but it's in there. And then it uses a ignition control module, and that ignition control module sends out spark, but also looks for senses, your flame, your pilot flame. And then we went over the intermittent pilot hot surface that's typically found in your smart valves. Oops, sorry, I keep bumping the thing here. When you're working with this stuff here, okay, anytime you're tightening this stuff up, well, first of all, this is aluminum. You want to cut this with a regular, small tubing cutter when you do this. But anytime you're screwing in one of these brass fittings to this, first of all, you do not, because it's brass and it's a soft material going into steel, you don't need pipe dope, okay? What you do need is 2 wrenches to do this, and that's about 7/16 and a 3/8 probably. So 7/16 to hold this, or an adjustable wrench, it's something to tighten this. It's called backing up the nuts. You want to make sure you back this stuff up. Same thing on this guy here, backing these all up. When you're getting with the thermocouples, if you look on here, I dropped it on the floor. Grab this guy here. Well, this is a bad example, but some of these, this one is not the one I was looking for. This one actually has a hexagonal shape for a wrench, but a lot of these are just like thumb knurling. So you can just, when you screw this into where it's got to go into, you just use your thumb and, like this. And realistically, you never really want to wrench these things in there because you'll never get it. You're not gonna say you're never gonna get out, but it's very difficult to get out if you use a wrench to tighten this stuff in here. You really just want to get these in there finger tight and as hard as you can go and leave it at that. And where you extend these to, kind of use, you don't want to kink this stuff, but you can kind of shape this where it looks, presentable. So I usually do something like, like that. So, all right, a little bit of tips and tricks here. So that's basically your three types of, or a few types of pilot assemblies that you'll come across most commonly, and those are found usually on older furnaces or your boiler systems, or water heaters have those. Garage heaters, a lot of things have that stuff. So, all right, hope that helps.